All right, guys. So today we're going to be talking about multiplying and dividing. The last section we talked about adding and subtracting, specifically the addition and subtraction properties of equality. So today we're going to look at the multiplication and division properties of equality. And basically we're going to be doing the same thing, except instead of adding and subtracting both sides of the equation, we're going to multiply and divide both sides of the equation. So here's a definition of the multiplication property of equality. It's just if you multiply each side of an equation by the same number, the two sides remain equal. Okay, so I have a quick example here. I'm going to actually make some room here. We know that 10 divided by 2 is 5. And if we multiply both sides by 4, according to the rule, it should remain equal. So let me move some stuff out of the way here. See if I can actually do that. There we go. We know that 5 times 4 equals 20. We just want to make sure the left-hand side over here equals 20 as well. So let's see. We have to follow the same properties as multiplying fractions as always. That doesn't change. So I've got 10 divided by 2 here times 4. But to multiply that, I have to write 4 as a fraction. Writing 4 as a fraction is just writing 4 over 1. 4 divided by 1 is 4, so it is okay to rewrite it like that. Write the rest of my equation. We know 5 times 4 is 20. So I got 10 divided by 2 times 4 divided by 1. You guys might be able to see this already. That we got multiplying straight across here. That's how we multiply fractions. Multiply straight across. 10 times 4 is 40. And 2 times 1 is 2. Well, does that equal 20? Yes, it does. 40 divided by 2 is 20 because half of 40 is 20. So we do, in fact, end up with 20 equals 20. The rule of this is just if I have an equation like this, that means it's balanced. A equals b. If I multiply both sides by c, then it still remains equal. So let's take a look at an example of using this tool. For what value of d is the equation true? In other words, we're going to solve for d. And in our previous videos, solve for d just means isolate d. We want to get it all alone, but right now, it's not alone. So how do we get it alone? Well, we got to remove everything else that's touching it. In this case, I have to get rid of this. This is fraction bar, -5. And it means we have to kind of recall what does this bar actually mean. And that bar actually means divide. So how do we get rid of divide? Well, you might be able to guess it. The way we get rid of divide is by multiplying. It's the inverse operation. It's like, how do you get rid of addition? Well, you subtract. How do you get rid of subtraction? Well, you add. So let's get rid of division by multiplying. So I'm going to use the lollipop because I am going to be working on both sides of the equation. I'm going to, instead of divide by -5, I'm going to multiply both sides by -5. All right, just follow me here. I'm going to rewrite this out as best I know how. Let's see, 7.2 times a -5, that's a positive, times a negative, and that's going to give me a negative, and 7.2 times 5. Let's see here, 5 times 2 is 10. 5 times 7 is 35. Add the 1 is 36 with one decimal place. So positive times a negative is a negative, and 7.2 times 5 is 36, so negative 36. And on the left-hand side, I am going to take some time to talk about this. I've got -5 times d over -5. We have to follow, still, like always, we have to follow the normal rules for multiplying fractions. In this case, I don't have two fractions. I have a whole number times a fraction, so I have to change this -5 into a fraction. We do that by writing -5 over 1, and then the rest of the equation. And follow the rules of multiplying fractions. I'm still going to be left with, I got -5 times d is -5d, and then 1 times -5 is -5 equals -36 still. I'll bring down my lollipop just a little further. And here I have a negative 5d divided by negative 5. Well, let's take a look at the coefficient here. I have a negative 5 divided by a negative 5 here. Well, negative divided by negative is a positive, and 5 divided by 5 is 1. D equals negative 36. And we know that we don't have to actually write the 1. That's that creepy coefficient. So we're going to be left with D equals negative 36. And as always, check your solutions. I know this is right, but I'll even show you how to plug it in. I start with my original equation, d divided by negative 5 equals 7.2. I'm going to be substituting d equals negative 36 into there. So negative 36 divided by negative 5. Does it equal 7.2? Well, we know that a negative divided by a negative is a positive, so far it's true. What is 36 divided by 5? How many times does 5 go into 36? Well, not quite exactly. It does go into 35. 7 times, though. With 1 left over, bring down a 0, and 5 goes into 10. 2 times, making sure to bring up that decimal. 7.2. Look at that. Looks like it works as a solution. Remember always to check your solutions. It's easy to make a small mistake in these kind of problems, and checking your solutions is a great way to tell you if you did or not. So here's a problem for you to solve. It says solve for the variable m. Go ahead and give that a shot by pausing the video and actually physically writing this down and solving for it. All right, well, here we go. I'm going to start by starting a lollipop because I know that I'm going to be working on both sides of the equation. I do see that it's a divide by 2. And how do you undo divide by 2? You do the opposite of divide, which is multiply. Make sure you're multiplying here. Instead of divide by 2, we're going to multiply by 2 on both sides. So on the left, I'm going to have 2 times m divided by 2 equals 6 times 2, which is 12. Multiplying straight across, I can't do that quite yet. I do need to rewrite 2 as 2 over 1. Now I can multiply straight across. 2 times m is just 2m divided by 1 times 2 is 2. Bring down the rest of my equation, equals 12. 2 divided by 2 is 1. M equals 12. And as we've discussed before, we don't have to write the 1. We just have to write m equals 12. This one's actually really easy to check. My original equation is m divided by 2 equals 6. Well, if I check m equals 12 and I substitute m in for 12, I'm left with 12 divided by 2. Does that equal 6? Yes, I think so. Here's another example with just a negative number. Go ahead and pause the video and see if you can do it. All right. Guess what I'm going to start with? Should be a lollipop. This just helps me remind me that I need to do the same thing to both sides of the equation so they can stay equal. I notice right away that this is a divide by sign. Divide by negative 3. How do you undo divide by negative 3? You multiply by negative 3. The lollipop reminds me to do it to both sides. So on the left here, I'm going to be left with negative 3 times m divided by negative 3 equals 2 times negative 3. This is a positive times a negative, so negative, and 2 times 3 is 6, so negative 6. All right. Follow the rules of multiplying fractions. I might need a little bit more room here in my lollipop. Negative 3 has to be rewritten as negative 3 over 1 so that we can actually multiply these fractions. And then multiply straight across. Negative 3 times m is negative 3m. 1 times negative 3 is just negative 3. Bring down the rest side of my equation here. Negative 3 divided by negative 3, well, that's a negative times a negative, so positive, and 3 divided by 3 is 1. That just leaves me with 1m equals negative 6. So m equals negative 6. And we're done. Plug this into our original equation to check it out. M divided by a negative 3 equals 2. Substitute in our answer, and we're going to get negative 6 divided by a negative 3 Is that equal to? Well, a negative divided by a negative is positive. Look at that. That is a positive 2. And 6 divided by 3 is 2. So, yep, we checked out. Looks good. Here's another example with just some decimals and with some negatives. And after this, we'll move on to the division property of equality. So go ahead and give this one a shot. Start with the lollipop, guys. Always start with the lollipop. And then notice that we have a division symbol. How do you undo divide? By multiplying. So how do you undo divide by 0.5? Multiply both sides by 0.5. Finish writing the equation. Got 0.5 times m divided by 0.5. Got a negative times a positive. That's going to give me a negative, and 1.3 times 0.5. 5 times 3 is 15. 5 times 1 is 5. Plus 1 is 6. And then move the decimal. Let's see, 1, 2 times. So 1, 2 times 0.65. Negative 0.65. And you actually might be able to already tell that these two numbers are going to cancel out, and it's just going to leave me with m. Okay, we actually don't need to take that next step. I just recommend it so you can actually see how it's working out. So m equals negative 0.65. That's our answer. I'm going to skip this one and move right on to the division property of equality. So in other words, if you divide each side by of an equation by the same non-zero number, that's kind of important, then the two sides remain equal. And the reason why non-zero is important is because you cannot divide by 0. So we just don't talk about dividing by 0. It's not defined. It doesn't even make sense to do so. So let's take a look at the example I've got here, the rules coming up. So 12 equals 4 times 3. I'm pretty sure most of us would agree with that. But what happens if I divide both sides by a negative 2? Let's see if that works. It's going to leave me with 12 divided by negative 2. Positive divided by negative is negative, and 12 divided by 2 is 6. Have a look at that. 4 times 3 is 12, and 12 divided by a negative 2. Well, we just did that here. On the left-hand side, that is negative 6. Does negative 6 equal negative 6? Why, yes, it does. So that does work out. The rule is basically this. If you have an equation where A equals B, and you divide both sides by C, as long as C is not equal to 0, then you should be good. Sorry guys, had a little technical difficulty there. Anyways, so the rule to this is if A equals B, then if you divide both sides by C, then it remains equal as long as C does not equal 0. Okay. In other words, you just can't divide by 0. Divide both sides by whatever number you want, just not by 0. So let's take a look at an example here where we can use this. So for instance, if I have negative 2 times P equals 1, can I solve for P? The answer to that is an absolute big yes. Just remember that this negative 2P is actually negative 2 times P. Okay, so I'm going to be working on both sides of the equation to get rid of that negative 2 out front there, that coefficient. So to get rid of negative 2 times P, we've got to get rid of that negative 2. Because it's a multiply, guess what we're going to do to both sides? We're going to divide both sides by negative 2. Just remember that this sign right here, this fraction bar, does mean divide. So here on the left, I'm left with negative 2p, all divided by negative 2, equals 1 divided by negative 2 is just a negative 1/2. And on the left here, negative 2 divided by negative 2, that's just 1. Bring down the p, equals negative 1/2. So p must be negative 1/2. We can substitute this back into our original equation. Negative 2p equals 1. I want to substitute this into p. It's negative 2 times negative 1/2 equals 1. Well, negative times a negative is a positive. That's what's given. We got positive 1. And what's 1/2 of 2? Well, that would be 1. So that does work out. See if you give this one a shot, and feel free to rewind to go back and check out those other examples. All right. I got 2 times t, or just 2t equals 6. Well, what does t have to be? You might be able to do that in your head, but let's show it mathematically. I've got to lollipop both sides because I know that I'm going to have to work on both sides of the equation. This is technically 2 times t, and how do you undo multiplication? With division. So we're going to divide both sides by a number. The number we have to divide by is that coefficient. So how do we undo this multiplying by 2? By dividing by 2. What does that leave me with? Let's see here. We got 2t divided by 2 equals 6 divided by 2, which is 3. 2 divided by 2 is 1. These with 1t equals 3, or just t equals 3. Does that work? Well, let's start by our original equation here and substituting t equals 3 into t. That's going to be 2 times 3 equals 6. Well, yeah, that works. Go ahead and pause the video and try this one out. All right, I see that I have a negative 3 times t equals 21. What does t have to be? Well, let's see if we can figure this out mathematically. Lollipop up first. Negative 3 times t. How do we undo that multiplying by negative 3? By dividing both sides by a negative 3. On the left-hand side, I'm left with negative 3 times t divided by a negative 3 equals 21 divided by a negative 3. A positive divided by a negative is a negative. And 21 divided by 3 is 7. So negative 7 there. Let's see here. Negative 3 divided by a negative 3. Negative divided by negative is a positive, and 3 divided by 3 is 1. So 1t equals negative 7, or just t equals a negative 7. Let's try that out though. Negative 3 times t equals 21. That was what we had originally started with. And I want to substitute t equals negative 7 into t. It's going to give me a negative 3 times negative 7 equals 21. Well, a negative times a negative is a positive, and a 3 times 7 is 21. So yes, this does work. Here's another example. 1.6t equals negative 32. And yes, this does have a decimal in it. You should be able to work with decimals by now. If not, use that calculator of yours. Go ahead and pause the video, give it a shot. All right. I'm going to lollipop because that's going to remind me that I'm going to be working on both sides of the equation. I know I'm going to be working on both sides because I have 1.6 times t. And how do you undo multiplying by 1.6? You divide both sides by 1.6. It's going to leave me with 1.6t divided by 1.6 equals negative 32 divided by 1.6. Should have kept that as green there. Sorry, guys. Well, this one could take a little bit more math. If you did it by hand, the way you figure out a negative divided by, let's start here. Negative divided by positive is negative, so I don't have to deal with the negatives now. I know what it's going to be. And what this is asking is how many times does 1.6 go into 32? The only way I can actually do this is by moving these decimals over once. This should be review. We may have forgotten it. Adding a 0, and that decimal comes up to this place right here now. So how many times does 16 go into 3? Well, it doesn't. How many times does it go into 20, though? It goes twice. 2 times 16 is 32. Brings down a 0, and then straight drop another 0. 16 does not go into 0, though. So 20, and we're done. 20 times 16 equals 320. But that means negative 32 divided by 1.6 is also negative 20. Okay. On our left-hand side of our equation, 1.6 divided by 1.6, you guessed it, is 1t, or just t equals negative 20. All right, here, let's do another example. Negative 9t equals negative 82. Pause the video, give it a shot yourself. All right, so negative 9 times t equals negative 82. How do we undo this multiply by negative 9? Well, we have to divide by negative 9. But whatever we do to one side of the equation, we have to do to the other. So on the left hand, I'm left with negative 9t divided by negative 9 equals negative 82 divided by negative 9. On the left-hand side, negative 9 divided by negative 9 is a positive 1t. And a negative divided by negative on the right-hand side is a positive, and 82 divided by 9. Well, we'll probably have to gonna do this one by hand here. So 9 goes into 82. We've already decided that a negative divided by negative is a positive. Keep note of that. 9 doesn't go into 8, but it does go into 82. So let's think there. How many times does 9 go into 82? Well, I know that 9 times, let's see, 9 times 8 is 72. 9 times 9 is 81. So 9 times 9 is 81, but that leaves me with 1 left over. And then drop down a 0. Let's put my decimal up here just to make sure I remember. How many times 9 go into 10? Only once. Uh-oh. Got something crazy happening here. How many times does 9 go into 1? Oh, it doesn't. Gotta bring down that 0. It goes into once. What we're going to see here is that this 9.1 just keeps on repeating, and we'll talk about more so what that means later here. So for now, we'll just round it to the nearest hundredth spot there and just say positive 9.11. So t equals 9.11. All right, let's take a look at just one more example and we'll be done, guys. Go ahead and pause the video and give it a shot. All right. Well, you should have started off with a lollipop because you're going to need to recognize that you're going to have to work on both sides of the equation here. The way we know that is because I have a negative 4.6t. It says times by t. How do you undo that multiplying? By dividing both sides. The lollipop reminds us. Negative 4.6 and negative 4.6 because we're dividing both sides. It's going to leave me with negative 4.6t divided by a negative 4.6 equals negative 2.2 divided by negative 4.6. Well, this one could be kind of nasty. If you have a calculator, though, it might even make it easier for you. Okay, how many times does 4.6 go into 2.2? That's what it's asking. It's kind of a nasty number there. We know it's going to be positive, and it looks like it's going to be just a little bit above a half. So here I am on the left-hand side. I'll finish that first. We know that 4.6 and these negative 4.6 are going to equal 1t, and that's going to equal sorry guys, more video technicalities here. We're taking a look at this right here, negative 2.2 divided by negative 4.6. And that's going to give me a positive number. It's a calculator problem, so 0.478260887. But for this class, we're just going to round that to the nearest hundredth, so 0.48 would be just fine. So t equals 0.48. All right, make sure to respond to this video in the comment section. Make sure you click reply if you're in my class. Click reply in Canvas and answer the questions that are given, okay? Make sure you're watching these videos and then replying to the to the discussion on Canvas, and I will see you guys tomorrow.